Welcome to Elektor Engineering Insights, the show that puts your engineering challenges to the industry's experts. I'm your host, Stuart Cording. Now, I love attending trade fairs. They're a great way to get up to date on industry trends and the latest technology. And they're also the perfect opportunity to catch up with the colleagues and partners I don't see daily, as well as meet up with old friends. So with less than a week until the Electronica trade fair in Munich, I thought it would be fun to recreate the mix of solutions and tech of an exhibition in this show. Today we'll be exploring ways of improving training for embedded engineers, looking at new families of microcontrollers and discovering a different way of making PCBs that doesn't even need the traditional green FR4 board. My panel of experts exploring these topics in this episode include Annette Kempf from EClipSigner, CK Phua from NXP and Roy Perez from Voltera. Welcome to the show, everyone. I'm going to start with Annette. So Annette, welcome to the show.
Thank you for inviting me.
You're welcome. Can you tell us briefly about yourself and your role at EClipSigner?
So my name, as you said, is Annette Kempf. I'm the founder and CEO of EClipSigner. So everything we're doing is from personal motivation, topics which I personally value and believe are very important. Yeah, and this includes the Embedded Academy, which we are talking about.
Super. Fantastic. Well, thanks very much. We'll hear more from you shortly. And then welcome to CK from NXP. Could you just tell us what's your role at NXP and what types of microcontrollers are you looking after? Can you hear me at all, CK? No, I think we've lost the connection there to CK at the minute. I don't think he can hear us at the minute, so we'll come back to CK shortly if I can. And then I'll just pull in Roy, our last guest today. Great to have you on the show. What is it that keeps you busy at Voltera?
Yeah, at Voltera, I'm the applications lead at Voltera, and we utilize additive technology to create circuits.
Super. Well, it sounds very exciting. I've had a look at your products in the past, so I'm excited to talk to you about some of the technology that you've been developing, and we'll be back with you shortly. See you in a second. So Electronica was the first trade show I ever attended, representing the semiconductor vendor National Semiconductor. We were showing off an internet-capable microcontroller, something that was quite novel at the time. Since then, I've attended countless trade shows asking questions on semiconductors and electronics. However, this show is for you engineers out there struggling with your challenges. So let's get your questions into us when you can. You can either use the chat function on YouTube and LinkedIn, or via Twitter, use the hashtag ElectorEEI. And we'll do our best to get those answers to you or guide you to some resources that might help. So let's bring Annette in, back from EClipSigner. Hi there. What I wanted to start with was asking you about sort of your career focus over the years. It's mostly been looking at automotive. And in that time, you've seen vehicles move from internal combustion engines, so petrol and diesel engines, to electric drivetrains. And over that period of time, the value of software has also grown significantly in automotive. What's been your experience of how the automotive industry has tackled these enormous changes?
Yeah, the changes are enormous indeed. Yeah, because it's not it's in different areas. So the microcontrollers have been growing, the possibilities, the interfaces, and so on. Lots of things have been changing in the industry. And of course, there also was a big change in combustion engine field in the beginning. So when it started, it was just a few components, and then more and more components got in, like lambda sensor, mass airflow sensor, EGR valves, and so on. So the amount of components increased, the communication within the vehicle increased. So this was due to legislation changes. Also, the legislation changes focused a lot on safety, which is bringing in more complexity. And then the last big step was now going from combustion engine to electrified vehicles. And this again is a huge step in the industry, because unlike in other electronics areas, in this field, lots of mechanical engineers started to work. And so the mechanical engineers needed all the know-how on the combustion, there's lots of thermal management, so temperature measurement, analysis in this direction. And now it's electronics and electrical engineering. So I studied electrical engineering, and many things I didn't need over many years. And now all of a sudden this came to be important again.
So from your perspective, what are the changes the automotive engineering teams have to deal with as they're moving from ECUs for an ICE motor to building ECUs for electric motors? Are there any skills that they can reuse, or are these engineers almost having to start again?
Of course, they can reuse many skills. So you have, I think this is the case for all of the embedded systems. You have to have a know-how of the microcontrollers, how to program the operating system, all these things. So this is your core embedded know-how. But whatever you are controlling with your embedded system, you need to have a deep understanding of the system you're controlling. And this changed completely from mainly mechanical parts to electrical engineering with the electrical machine, with the inverter, battery management systems with cell balancing and so on. So you have to learn your system new, and it's more or less a new product which you're developing. Yeah.
Exactly, yeah. So there's an enormous amount of change, and like you say, it's basically a new type of product entirely. It's completely different to the timing and control of an ICE engine. So when it comes to sort of the education which students are getting in universities and colleges, are they receiving the skills that they need to actually sort of be effective straight away in the automotive industry?
Of course not. Yeah, but I would say this also makes sense. So what tasks do universities have? Universities need to prepare the people for a full work life in the industry, which is maybe 45 years. And many things in the automotive industry are quite new and might not be there forever. So you have automotive standards like automotive cybersecurity, automotive SPICE processes, AUTOSAR. These things are going to change, and maybe in 15 years, nobody will know AUTOSAR anymore. You don't know what's going to happen. And I think the universities have to make sure that you have a core know-how, the technical know-how to be able to tackle new things. But there certainly is a special gap on specific industry topics, because people might start in automotive, might start in medical or in other areas. This doesn't have to be predefined. This is one thing. And of course, the other thing is that they are coming from different curricula. They studied different subjects, which I consider also as very important because you need a certain diversity. Diversity is like a modern topic, but you need also a diversity on what you studied, where you have your deep know-how in, to have a big amount of knowledge within an organization. But this means also that you have certain gaps to fill, which of course university didn't provide, and which are specific to the job you're entering.
So there's definitely sort of a gap there as students come out of universities and colleges and enter into the automotive industry in order to support their colleagues in developing these electric vehicles. Now I know Eclipsigner has been very busy developing an online learning platform, the Embedded Academy, and that offers a lot of training relevant to automotive electronics and automotive systems. How did that platform come about?
Yeah, there are different things. The platform itself, like the idea of a platform, is something what I would always have wanted for myself. To be able to fill in idle time, for example, a long going build process, or to if you wait for requirements, if you have some idle time which you could use to learn snippets. This is one thing. The other thing is that of course I want to learn on demand. When I need it, when I need to know something, I want to search for it, and I want to be able to do it now, and not doing a planning for half a year, 1 year in advance, which training I'm allowed to participate to later on. The topics themselves, we started with some classical embedded topics, and we've been working together with a huge automotive tier 1 to set up trainings. And this is more or less which brought my automotive know-how and their know-how together. So there we've been working together with almost 30 experienced engineers in the automotive and especially in the e-mobility domain. But so this is the reason why we focused on this, but we will enlarge the scope, and we will build up a learning landscape step by step. For example, now we are doing some measurement technology, adding this. We are working on IT security. We're working on field buses soon. So we made a concept. So it will not stay just e-mobility and automotive. It will grow, and the borders will also get broader and broader and broader. Yeah.
Sounds very exciting. It's nice to hear there's a plan and progress for expanding the portfolio of training. So who is the Embedded Academy primarily aimed at? Is it for graduates who are entering the automotive industry, or is it is there room for sort of tenured engineers who are looking to reskill as they maybe move departments?
Of course, for onboarding, it's perfect. There are so many gaps to fill. This is a good chance. And exactly this feedback we got from one of our customers, that they saved money due to the fact that their experienced engineers saved time and could work on customer projects instead of training the newbies. So this certainly helps the organization, taking pressure from the experienced people and support the onboarding. But if you're switching your position, it's certainly also interesting, and to reskill for sure as well. So I'm doing all the reviews, the final reviews of Embedded Academy e-learning units, and more or less every unit I had a look at, I learned something for myself again. Yeah.
That's great news. I think if anyone were to say that they'd looked at some material like this and not learned anything, I'd be very surprised. So the training, I've looked at the website and seen what you have on offer, and the training courses span everything from sort of introductory level to very complex topics. What are the most popular ones currently amongst the user base?
This is difficult to say. I think the most watched one is cybersecurity topics, and in this area, encryption. So encryption is the one which is looked at the most. And then I think the next topics are AUTOSAR and operating system, real-time operating system. So it's for a broad span, and it's most of them are evenly used. So it's not like one highlight and nobody interested in the other stuff. It's equal. Yeah.
Yeah. No, super. Now, I think the encryption and cryptography elements and security are critical parts of the automotive industry. So, it's that doesn't surprise me. So when it comes to the platform, there's lots of different courses available. How can I access the courses? Do I purchase individual ones as I need them, or how does that work for the users?
We made the access quite easy, so there's just one product, and this means access to everything.
Wow.
And the pricing is according to the time. So if you buy a shorter time, it's cheaper, and a longer the time is more expensive. And this means even if you bought access for several months, we are changing the product, but nobody's complaining, because changing the product means that we are releasing a new e-learning every other week. This is the average, and this is also I got as a feedback from a customer. He said, "Yeah, you think you did everything, and then there's something new again."
That's great news to hear. And what's it like in your experience? I mean, obviously, it's nice to have a platform that's online, because then I can, as you've already explained, I can go there and look up a course and participate in it. I can redo the course as well if I want to go and refresh my memory. But what are the challenges that engineers have in getting access to training? Especially in the past, training has always been an in-person course, and you've had to take time off and book a hotel and things. Is that a challenge for people?
I don't know if it's like a challenge in terms of budget discussion. Yeah, there are some challenges because there are some huge platforms which have like 20,000 trainings. Yeah, and then you get the feedback from especially HR departments that they have a partner which has 20,000 trainings. But if you need, like, for example, electrical machines or like encryption or real-time operating systems, then agile project management won't help you, and also not working security and some other stuff. Yeah, so I think we're specialized, and it's necessary to do the internal communication and say, okay, but these are exactly the topics I need right now, and it's interesting. And for the access, you can just buy over the web shop, or it's possible to buy multiple access for many employees, and then we'll create the accounts and provide them. So concerning the purchasing process, it's easy. Yeah.
Yeah, super. Well, thanks very much for those insights into the training platform and what's available on it. We'll stay on the line, because we're going to come back to you later and see if we've got some audience questions for you to answer, and join us with our other guests later on. So thanks ever so much.
Thank you.
Super. So now I'm going to move on to CK. We've had a couple of problems getting some access, but he's smiling, which means he can hear me, which is really good. So welcome to the show, CK. It's lovely that it's all worked out at last. Let's just start off. Explain what's your role at NXP and what types of microcontrollers do you look after?
Sure. I'm the product manager for the microcontroller section. We do have a broad range of microcontrollers. It starts from the lowest end, with on-chip flash, and it goes all the way to those equivalent to like a MPU without the on-chip flash. We call it crossover. So there are different product managers in charge of that.
Super. Now, when I was at Embedded World this year, we got to see the launch of the MCX microcontroller family. Can you tell us a bit about how that family came about and what types of applications it's focused on?
Sure, sure. Interesting. If everyone remembers the 2015 December, Freescale and NXP merge. It came along, with a big, two portfolios as from the LPC microcontrollers and from the legacy NXP, and there's also the legacy Freescale Kinetis portfolio. So this merger brings along these two mega portfolio. The management decided to leave this alone because there were so many users of LPC and Kinetis of the microcontroller. So we left it alone, and after several years, we think this is a good time now to introduce the new portfolio that picks the best of Kinetis and the best of LPC together. So this MCX is a consolidation of both. But keep this in mind that we are still continuing to supply both LPC and Kinetis, so just be aware of that too.
Yeah, super. Now there's four sort of families within the MCX range, and the N series to me looks like it's the most powerful. What types of applications are you trying to address with MCX N microcontrollers?
Yeah, so this is the first product we introduced. We're going to have four series in there. So the N series is definitely the highest of that. We are focusing products that are kind of always anticipating, able to process and not draw the power of a lot of power that you always need to be connected to a wall plug. So this focus actually for microcontrollers are very key, giving the performance, also making sure the power consumption is always reasonable for any application.
And what are the other key features of the N series family?
Yeah, so let me bring out a slide to show.
Yeah, we can bring that up here. Hang on a second. There we go.
Yeah, so the first N series we do have a multi-core in there, so we have dual core, dual M33 core in there. But besides just the CPU, we also offer as a microcontroller, we offer a good amount of flash, that 2 megabyte of flash in there. There's also optional full ECC RAM. There are accelerators that you can use to speed up things related to the application you need to work on. So, for instance, there's a neural network processing unit that for AI and ML stuff we can do it. There's also a smart DMA where we can take streaming data from any channels, whether it's coming from a camera or having an audio. We can stream it in. It'll just do all the work for you, do some pre-processing without the need for the CPU to do it. There's also a DSP engine that we can do DSP work on that as well. For this platform, we also added a co-processor where they can also do power line communication based on the CoolFlux DSP processor. The chip itself is really trying to get everyone to think about distributed processing. So essentially, marking it at 150 megahertz, not to consume a lot of power, but give you all the options to turn on when you want to. Peripherals is also critical because without the peripherals, you don't have the chance to get in and out of the microcontroller. So this a rich set of peripherals also added onto it. In the embedded world, the security now become a very critical item. So we also have a secure subsystem in there where the application can determine what they want to lock, what they want to enable at the time, and we provide all the mechanism for the application to decide where the life cycle is going on, and they can progress the life cycle such that the products in the field are not being hijacked and or copied in any way. So these are essential items nowadays for the security subsystem.
Okay. Now, as you already mentioned, these devices are based upon ARM's Cortex processor family, specifically the Cortex M33, and that's quite relatively new. We haven't seen so many of them in the market. What sort of performance does the Cortex M33 deliver, sort of compared to the older cores such as the M3 and the M4?
Yeah. So when M33 is a relatively new core, maybe 3 to 4 years, I would say. But when M33 came, it was showing a lot of attachment that we can use. So beside the 20% improvement over the M3 and M4, M33 comes with options to do coprocessor instructions. Then you can attach accelerators, and that's what we are doing today. So we activate this feature. User can decide, to call upon the MPU, or to call upon the smart DMA, or to call upon any of those accelerators that we offer to you and use it. So if we remember, microcontrollers itself, we are pretty focused on moving data, processing some data, and then getting, servicing the outside worlds in terms of the interrupts, the DMAs, and the IOs. So the having options to do multi-core and options to do acceleration brings the user the flexibility to say, okay, I can leave the task here, do the other task first, and so on and so on.
Yeah. Now, multi-core devices obviously offer more performance. I've got 2 cores there, and I can share the work. And in an operating system like Windows or Linux, all the complexity of that is sort of taken away from me. But for embedded firmware developers, we have to sort of make more decisions. We have to be more specific about how we want to partition our application between the cores. What do developers working on your processors do? How do they approach that partitioning of their application across the cores?
Yeah, we actually did some thoughts. This is not the first dual core that we introduced. So if we take a step back and look at the previous product that we have with a dual core, we normally offer a little bit of a kind of downgrade or asymmetric core, where the first core is usually the more loaded, where you have full features of all the M33 with we have the trust zone, we have all the FPUs and so on. The second core, where we typically put a very basic core in there, so users can use that as a very kind of a workhorse to do basic IOs. You want to do handling of interrupts and so on. So in this context, a very simple approach would be, if you have a secure application, you want to put it on the first core where it has the trust zone, and the non-secure application, you can always set it in the second core and do it. And the symmetrical core of M33 give the user similar development environment. You don't have to keep thinking about different performances that you have. You're running on the same bus. They have both access to all the peripherals simultaneously.
Okay. Well, that sounds like a good approach, and I think that's sort of one of the challenges engineers often face as they move from a single core device to a dual core. One of the other interesting parts of this family is, as you already mentioned, is the neural processing unit, and we're seeing an increasing number of edge machine learning algorithms to sort of do image processing or process sensor data on industrial machines. How does that work in this family of devices, in the N series devices? Is the neural processing unit something I can program myself, or do I use some libraries or something like TinyML to prepare my machine learning model, and then it sort of the MPU works as a black box?
Yeah, cool. So very good question. This is the first MPU for microcontrollers that I would say is being introduced. Previously, a lot of application were focusing more on the application processor class, where they always take on the information, go to the cloud, come back, and do also some services on that. What is really big there is that they already have a very established set of algorithms, set of things in there. So what a microcontroller approach is always different, because they are focusing on products that are at the edge. They have to make local decision. They cannot always depend on the cloud. So the idea here is to make the processing local, and we're going to be kind of allowing users to check out our tool. We are providing a tool that we call it EIQ, that will support all the algorithm that used to be in the MPU world, where there's a TinyML. There are options to do in a different way of coding and encoding and all the selections, and distill that in the PC, the train value, and download it onto this chip. So this chip will make that local decision to say, if I have a streaming information coming from a camera that shows, say, a face or human count, and then we can do that counting over, the camera, and rather than just waiting to go back to the cloud and say how many people I have, and then report back again. So that's the whole intent. So the proposition here is to make all this ML happening at the edge here.
That's great. I think that's also the way a lot of the industry is moving in the microcontroller space, is to bring that ML directly onto the microcontroller. So it's great to see. There are also two DSP blocks, and I think you mentioned that the cool flux one is used for power line communication, and then there's another one called power quad. What's the difference between those two DSPs, and what sort of applications would I be tackling when I'm using them?
Okay, so for the cool flux, it is a full, I would say, a fully standalone DSP. So we code it as a coprocessor, meaning when the M33 issue a run command to the cool flux, essentially cool flux is on its own. There will be a different development environment and so on. As a start, we offer cool flux as a pre-programmed power line communication. So our application guys will offer the support and giving them the binaries and codes to help them. But the cool flux is always open to users who are trying to explore more with the cool flux DSP. And by the way, cool flux is an NXP DSP.
Okay.
On the other hand, the power core is acting like an accelerator. So if we remember all the Mac instructions, and if you have to do something related to audio, or you have to do multiply accumulate in a loop fashion, even with a M33 and the improved SIMD instructions, it still could not match a good DSP. So we find the power quad as a very generic accelerator that can help this operation. So we've seen performances between 5 to 25 times improvement over the M33.
Super. Well, thanks very much for the answers to those questions. We need to move on now because we're starting to run out of time. So stay on the line in the studio there, and we'll bring you back in later for our Q&A session at the NCK. Thanks very much. Super. So now it's time to have our competition. I just need to find the details so I can share them with you. There we go. So I need to turn that off as well. There we go. Yeah, so first of all, thank you ever so much for supporting the show and joining us today. We have an ESP32 Smart Kit bundle up for grabs for those of you who are watching. In the box, you'll find an ESP32 board, a breadboard for prototyping circuits, and a collection of components and sensors to get you started. Helping you with your first coding experience is the complete ESP32 project guide book written by Dogan Ibrahim. Working through each project, you'll discover how to use the Arduino IDE and write applications in MicroPython. If you'd like to participate, use the link that you see at the bottom of the screen here and enter the keyword training, that's the keyword training, with your entry. All the best and good luck. So that brings me on now to our final guest for today, Roy from Voltera. Hi, Roy. Thanks for waiting patiently there in the background.
Yeah, no problem. Thanks for having me, Stuart.
Super. It's great that you've been able to join us. Now, at the core of any electronics system is a printed circuit board. It's typically green with all the components soldered on. And those boards, they need sort of aggressive chemicals or even a CNC machine to prototype them. But Voltera has a different approach for prototyping. Could you explain, the background here?
Yeah. Voltera utilizes, like I said earlier, a direct ink write approach. So we deposit an electronically functional material onto a variety of different substrates. So with the V1, we deposit a silver conductive ink onto bare FR1 and FR4 substrates. And now with Nova, which we released on October 4th, we've opened things up for product developers and researchers to really start exploring the different possibilities in additive electronics.
So the V1 has been around for a few years now, and although it's delivered with FR4 board for prototyping, I know that a lot of users had been trying to make boards on flexible substrates. I think I can't remember that orange material that Kapton tape, for example.
That's right.
So what were you seeing researchers doing in the space of flexible circuits that made you think, hey, we need a new printer?
Yeah, it's incredible to see what people have really pushed the V1 to do. They really pushed the boundaries and were hacking the V1 in a sense. But we've seen people develop things like glucose sensors, VR gloves even. Wow. We've seen researchers print onto carbon fiber composites for de-icing applications on UAVs, for example. And we've even seen researchers use the V1 to create microfluidic molds, which is something that the V1 was not created for, right? It was truly meant for traditional electronics, the green PCBs that you described.
So as you mentioned, you've just introduced the Nova printer. I think the launch was last month, and
That's right.
This printer is specifically for flexible substrates. Can you tell us a bit more about how that printer works and some of its capabilities?
Yeah, I love to pull up some slides as well,
Stuart, we'll do that.
And we can kind of show a visual as well. But Nova still utilizes that direct ink write additive approach, but we have opened it up to allow users to print a wide range of screen printable materials onto a variety of different substrates. So things like flexible plastics and stretchable materials, for example. And that's sort of just the beginning too. With additive electronics, the value chain of additive isn't as well established as traditional electronics, as we know. But we've designed Nova with modularity right from the get-go, so that as projects change, as research change, as your circuit design changes, Nova will also change with you.
Now, when I was looking at the website to research a little bit more about the printer, the thing that really comes out and strikes you from the first page is that you can print onto any material. But my experience with the V1 that I had, my understanding was that the tracks need to be the tracks that are printed need to be cured through a heating process. Yes. So does that also apply to Nova? And if so, sort of what are the materials that are commonly being used as a substrate?
Yeah, that is still the same case with Nova. Some common materials that we've seen, flexible plastics, so PET and Kapton that you've seen and talked about, and stretchable materials, so TPU for things like on-skin type sensors or integration into textiles and fabrics, so denim or any sort of safety clothing, things like that. Coated papers, smart packaging, lignin coated paper for on-skin electrodes as well. Carbon fiber, for example, carbon fiber weaves, PDMS, and that's more of a silicone-based organic polymer. And it's, I guess, the compatibility between the materials is sort of where things, I guess, get a little trickier. You asked what works well and what is a little bit, where does the thought need to come? So it's not so much with the substrates themselves, but it's the compatibility between the substrate and ink. Because Nova uses such a wide range of materials, because it's so flexible in what you dispense and what you dispense onto, understanding the relationship between those materials is the key there. And luckily, there are material manufacturers, for example, DuPont, that have developed compatible material sets for specific applications.
How is it with the ink for this particular printer? Is it still a silver-based ink, and is there something in that material that allows it to be flexible once it's been cured?
Yeah, it's sort of like a resin in a sense, and you're not limited with just the silver conductive ink with Nova. We've had people try to print copper. There's a company that produces a copper based ink, graphene, carbon, resistive materials as well, and what kind of, I guess, allows that flexibility is really the interaction between the polymers and the organics of the material itself. So it can withstand certain bend radiuses to a certain degree.
Now, one of the things with the V1 printer, when I was using that, the FR4 board has to be sort of affixed to the base, and then there's a probe that comes out and calibrates the surface. But I can imagine with a flexible substrate, a flexible material, that there's some give. So yes. How do you find out where the surface is that you really want to apply the conductive ink to?
Yeah, so both machines utilize a XYZ positioning system and a probe. That principle hasn't changed between the two products. It still is able to map out the substrate and determine exactly where that surface is in real space. With the V1, it was designed purely for those flat and rigid surfaces. Where Nova sort of changes is the ability to get more accurate measurements, and we do that by using strain gauges in the XYZ positioning system. And that allows us to not only print onto rigid and flat surfaces, but also things like curved surfaces. And sort of, I spoke about modularity at the beginning there, and we could potentially come up with a module to expand that even further.
Now, one of the things that really struck me with your solution is the software. It's very, very intuitive. It provides a nice graphic screen which takes me through the process of setting everything up. Is Nova using the same software, and is the process for starting the machine and preparing it the same sort of approach?
It is a very similar approach. It doesn't use the same software. Nova is actually a web-based app. We've kind of transitioned into that just because it's more readily available for users. We take great pride in developing beautiful UI, beautiful UX experiences, and that's a foundational piece for us at Voltera. So that has been carried out through Nova software, and you'll see that in very similar in the guided processes that you mentioned. So it kind of walks you through each part of the printing process and really kind of holds your hand throughout the whole way.
Now, the other thing is that the conductive ink, people are very used to using copper. Obviously, that's a standard material that gets used in most applications. When I'm using these silver-based inks, are there any sort of things like limitations on power that I can conduct, or the frequencies that I can apply, or the track dimensions?
Yeah, that's a great question. So we're sort of talking about two segments here. So when we're comparing a conductive or printed PCB for traditional electronics manufacturing. The V1 addresses and is capable of covering, up to 90 to 95% of the applications out there. But there are those limitations, like you said. So there's still those power limitations just due to the maturity of the traditional electronics value chain. We can't essentially compare apples to apples there. So in terms of the limitations specifically, 2 amps at 5 gigahertz and about a 0.2 millimeter trace width is sort of the limitations with a traditionally a board printed for traditional applications. But now when we talk about additive electronics, those same limitations aren't necessarily there. Because you can start using different materials, conductive materials, higher conductive materials, for example, carbon nanotubes, or even just different substrates, you kind of open up that spectrum of possibilities. So you don't have those same limitations, and you also don't have the same application. So when I talk about traditional electronics, we kind of think about traditional electronics like your phone, your cameras, your television, sort of a board in a box type of electronics. But with additive, now we're talking about things like in-mold structural electronics, where the electronics are embedded directly into the box itself. They're no longer separate or kind of two entities anymore. You're talking about things like wearables, on-skin, flexible, or smart clothing, for example. Those are now possible, and you're able to do that with additive electronics, and even large area applications, electronics that can span buildings or cities, for example. So while there are limitations in terms of the traditional side, in terms of additive, the possibilities are wide open.
Well, thanks ever so much for providing us insights into Nova, and I think it's a really exciting space, and even 2 gigahertz and 5 gigahertz and 2 amps is probably more than enough for most people's applications, right. Especially when they're at the prototyping phase. So yeah, I think it's a very interesting and exciting technology, and looking forward to seeing it. Yeah. So I'm just going to bring everybody else into the show now to have a little bit of a roundtable discussion and answer a few questions from our audience. So welcome back again, everybody. I'd like to start with a question to Annette. Will you be coming to Electronica in Munich next week? We need to turn your microphone on.
Switch off the micro. Yes, I will come, but I will be there only as a visitor, because this gives me the chance to meet more people than just having a booth. Sorry.
No, exactly. Definitely makes sense. So if somebody wanted to meet up with you and have a chat about Embedded Academy, what's the best way to reach out to you before the show and maybe make an appointment?
Yeah, would be good. Just send an email to the official email account, like info@eclipsiner.com. Yeah, and then I will get back to you.
Super. And Roy, I understand as well that Voltera is going to be with us actually at Elektor. We have a stand in Hall B4, number 440.
I'm glad you remembered that.
Do you know what is actually going to be on display and what people will be able to see at the Electronica show? Yeah, so we will be bringing a Nova machine out to the show, and we'll also be doing a presentation as well throughout the week, just touching base on the things I discussed, the in-mold electronics and wearables applications, just in a bit more detail. But yeah, come say hello. We're always happy to chat additive. Great. And CK, I know that NXP is going to be at Electronica. I think you are in Hall C2, stand number 578. Will we be able to see the MCX series of microcontrollers?
There will be a demo over there. It will be a demo showcasing the ML capability of it. For visitors, feel free to go there and check it out.
Super. That sounds great. I will definitely be dropping by. I have an appointment already made in my calendar, so I don't know if you know that, but I do. Super. I'm just going to take a quick look at our list of questions. There's actually one here for CK. This one's from Czeslaw Stoduli. I think that's correct. And they've asked, is there any sort of framework provided for the machine learning training process on the MCX? And I think you mentioned a little bit about the training of the machine learning capabilities. So maybe you could just explain how a model is created and then transferred to the microcontroller.
Yeah. So we all know, today a lot of these models are available, whether it's MobileDAN, TinyML, and so on. We can use the existing ecosystem to do all those training to really pick up the benefits of moving it to a microcontroller. We do need to condense it. So NXP provides a platform called EIQ, where the customers can take on whatever they have trained on the current software and just move it to the EIQ platform. And that's where you get the models in there and then distill it to variables that like an output object file for the micros to pick it up from there. Yes.
Super. Lovely. Well, Czeslaw, I hope that answered your question sufficiently. If you have any more questions, feel free to drop us a line and we'll try to get some more answers for you. Or if you are able to, join us at Electronica next week. And then I have one here also from Ari. Ari asks to the Voltera group, is the cured ink solderable or do I have to glue the components on?
Yeah, that's a great question. It is solderable. You should keep in mind that it requires low temp solder. So it's not your traditional high temp 350 degrees solder that you'd apply. So, and the reason for that is just the conductive ink can't withstand high temperatures. Otherwise you start affecting the adhesion. But the cured ink is solderable using low temp lead-free solder.
And does that also apply to sort of the flexible solder as well and the different substrates that it might be applied to?
Yeah, and that's kind of the piece in terms of compatibility that we'd have to keep in mind, especially when soldering, understanding sort of that relationship on how it solders and if it's solderable, how it'll interact and adhere to a flexible substrate is very important information to know. You could, if, for example, you could potentially damage a flexible substrate if the wrong materials and the wrong temperatures were used.
Right. So that means if I wanted to, it would be possible to maybe use solder paste, an appropriate solder paste, place the surface mount components onto the substrate and even maybe put it into an oven if I set the temperature curve correctly?
Yeah, that's correct. And there are other possibilities as well. You're not just limited to solder paste. So another material that you can print is an adhesive, electronically functional adhesive. It's similar, but can withstand different and has different functionality.
Super. Well, there you go, Ari. That's an answer to that question for you. I hope that helps you to understand better how the Voltera printers work. And again, if you have time and are available, you can come and join us at Electronica next week too. Annette, you do lots of prototyping as well. How do you do your prototyping? What sort of platforms do you use and services do you use to get your print PCBs manufactured?
Honestly, we are asking manufacturers to do this for us.
Right.
So we buy it.
Yeah.
Yeah, we have these charging test systems and also this controller for the charging stations. And we had all of this done externally because we don't have enough expertise in this field. Yeah.
Mm-hmm. Super. And CK, with the N series processors, I was just looking. I'm just going to get my notes here because I was printing out the system here. With the secure subsystem, we have the edgelock, which I think is a technology from ARM. How do we go about using edgelock to make an application secure?
Yeah, I think NXP has branded the edgelock. So this is an NXP brand edgelock. So we do have traditionally if everyone have seen a lot of NXP security products. We are leaning on the Big Brother framework where they are providing security to passports, to all the financial bank cards and so on. So the edge lock is essentially a secure element grade type of quality that we are giving out. So users can ensure can be assured that the chips are being tested for glitching attack, for people trying to bypass any way that they are trying to think of. But obviously security is a price of how much you're willing to pay, right? So so if you have a chip that is fully locked and so on, then it's a different class of products as well.
Yeah. Super. And Roy, you're based in Canada, I think. Is that correct?
Yeah, that's right. Kitchener-Waterloo, just an hour away from Toronto.
Yeah. Now, there's from my experience at least, there's been a bit of a different, let's say, outlook or expectation of trade shows. My feeling is that sort of in Europe we have a trade show is where people come and exhibit, and in the US, at least from what I've seen, trade shows typically tend to be linked to some sort of conference or a congress, and people sort of need to have something that they can learn when they go there, and the exhibition is sort of just bolted onto the side. Is that your experience as well?
Yeah, exactly. It's been difficult, I guess, for the past couple of years to get out to a trade show, but we're doing what we can to show up and to get our name and products more well known. And it's been exciting to participate in some of these virtual events like you're hosting as well, Stuart. And we are doing a lot more trade show planning for the upcoming year as well. So hopefully we can get out there.
And you think trade shows are still an important part of our industry?
Absolutely. And at the end of the day, it's relationship building and getting to meet the right people. And I don't believe in luck, and we have to sort of create luck, our own type of luck. So definitely getting to trade shows and getting to meet the industry leaders like CK and Annette is very important.
And Annette, the same for you. How's it been the last couple of years with COVID and restrictions on meeting people at exhibitions? Has that been a challenge?
Yeah, I think it has been a challenge because you didn't meet and then all the exhibitions were put into a small time span. So everything happened at the same time. So you couldn't go either. Yeah. And it was also interesting to see some of the booths really small because bigger companies had to, had parts at this exhibition and part at the other exhibition taking place more or less at the same time. So I'm really happy to get back to normal again. Yeah.
Super. And CK, what's it like for you? Do you enjoy the opportunities that exhibitions and trade shows bring?
Yeah, we have been always in the trade show. Just like for the last few years, with this restrictions of COVID situation, NXP tried to create virtual trade shows. We even virtual tech days. There's a lot of effort, but it's never been the same with talking face to face with customers, showing people and then getting the direct question as to see their reaction as would they be wowed by the chip or would they be wowed by the product, and that's different. Yeah.
No, exactly. Yeah. No, I think it's critical. And yourself, will you be going to Electronica next week?
I won't be going. I think we have a European crew representing us there. Yes.
Super. Great stuff. Well, thank you ever so much to all three of you for your time and your support and for answering those questions. I'm just checking here to see if anything extras come in, but there's no extra questions. So thanks ever so much. And I'm just going to wrap up the show. So thank you.
Stuart.
Thank you, guys.
Thank you.
Thank you.
So the great thing about the semiconductor and electronics industry is that there is always something new, some technical advancement. Regardless of whether you're looking for ways to improve the training offered to your team, searching out a microcontroller platform that can support your business for the coming years, or if you need to rapidly prototype circuits on flexible substrates, trade shows like Electronica are a fantastic way to discover these innovations. Furthermore, you'll find like-minded attendees like our guests today, all willing to share their experiences and the pitfalls they've overcome. And that, after all, is what the engineering community is all about. Thanks to my experts Annette Kempf from EClipseSigner, CK Phua from NXP and Roy Perez from Voltera. You've delivered us with some brilliant engineering insights. So that wraps it up for today. If you're going to go to Electronica, don't forget to drop by Hall B4, stand 440, and you can meet up with us, the Elektor team. We'll be broadcasting live from the trade show floor on the Thursday, that's at 1700 CET, and at our stand you'll be able to see how the Elektor magazine and our online articles get published. There will also be a prize giving ceremony for our Fast Forward Award participants, highlighting outstanding startups, and the World Ethical Electronics Forum is around on Tuesday, and there we'll be searching out how we can be more ethical as engineers. While you're here, please subscribe to Elektor TV on YouTube and share our videos on whatever platforms you use, or just drop by the website at elektormagazine.com/Elektor Engineering Insights to see the topics for future shows. If you'd like to join me as a guest, write me an email, drop me a tweet, or reach out to me, Stuart Cording, on LinkedIn. Thanks for joining, stay in touch, and don't forget to keep asking your engineering questions.